Hi guys, good evening all of you. Hope all of you can hear me. Anyone guys, can you please
Yes,
confirm if I'm audible? Yeah,
Yes, we can
yes,
hear
Audible.
you.
Vamsi.
yeah guys. So guys, let's continue. Anyone guys, any questions if you have? So yesterday we have been little bit, there is a disturbance was there. I think now today it was clear. Yeah. Anyone guys, if you have any questions from the yesterday's class, if you have, let us have a discussion and then you can go ahead.
Yeah, hi, Vamsi. This is
Yeah,
Narendra.
yeah, hi Narendra. Yeah.
Can you repeat regarding about yeah? Can you repeat regarding score and prediction? Yeah, prediction. Like,
Yeah,
can you
okay.
repeat it again?
Okay, I'll do that. Okay, fine.
Yeah.
So I'll just show you one example so that you can understand what is meaning of a score and what is meaning of a prediction. I'll show you with a
Excuse
better
me, sir.
example. Yeah, yes, guys. Yeah,
Is it any continuous class at the middle of the course? I mean, they told me like it was a demo session, sir.
yeah, it's a demo. Yesterday we have started the demo. It's a demo only. Just yesterday one session. It's only just an introduction part, like what generally we do, because see, everyone won't join on the first class itself. Up to next 1 week they will join, and then we'll consolidate all that particular sessions. Like we don't repeat it, but they will be slowly. That's why these are only introduction classes. We're not going to start with any much practical sessions. Just an introduction part, like what is data science, why we are going to learn all these things. We are going to be discussing about that.
Sir, can you give a walkthrough for 5 minutes
Yeah,
about previous section?
yeah. I'll tell you. It's nothing technical aspects. I'll just tell you like what has been happened once again. Right. So yeah, guys, any questions if we have, I can just have a discussion about that. Okay. So once again, guys, what is basically a data science? As we discussed it that we are going to be using a different techniques. We have some data, we have a different techniques are there. And apart from that, as I told you, it is we are going to use a different types of methodologies. We are going to use a different types of systems, processings, and apart from that, the different types of algorithm. So what is our target is, guys? Our target is going to be nothing but, our data science target is nothing but, guys, which we have to study the data, guys. Learn the data or learn from the data, study the data, guys. We have to study the data. We have to learn something from the data, study, or what we call it as learn from the data. So it is nothing but learn from the data. Based on whatever you studied and whatever we have been learned, based on that, we can do some kind of an prediction can be gets done, guys. That is what exactly the data science we are talking about. So for that, what are the different techniques we require? What are the different methodologies we are going to be using? So we'll use all the different techniques and methodologies to study the data. So it's a little bit, we cannot explain like we'll write a program, we are going to get the output, etc. So that is what we have been discussed about that. So machines are nowadays, what they are saying is, up to now, what we used to say that machines can't take the decisions by themselves. So we have to give some instructions in a format of program. So what we have thought up to now is, if you write a program and give it to the machine, machine is going to execute the program. Depending on the logic you write, whether you write right or wrong, depending on that, the machine is going to, the computer is going to run it and gives the output. Now what we are saying here is, machines are now became intelligent. Now the machines has become very intelligent. Now they are saying that you need not to tell me what is the logic. You tell me what is your data. I will study the data, and based on that, I can make that particular predictions can be gets done. That is what we are talking about that. That is what we are talking about that. So machines has become very intelligent with some not with natural intelligence, with some artificial intelligence. They have got some ability to learn. So with that ability, they are able to learn the data, learn from the data, and based on that, it is going to be, we are going to be giving, or we are able to perform some kind of a predictions, guys. So the task which where the machines are going to learn, that is what we call it as machine learning, guys. So in machine learning, what we are going to do, guys, there is a data was there that we are going to feed the data to the machine. Machine is going to study the data and it is going to give you some insights. Based on that insights, we are going to be doing some kind of a prediction. We are going to do that. But only what we are going to do here now, machines are going to learn. but how much efficiently the machine learned, that is what the score is talking about. That how much extent it learned correctly, how much extent it is able to predict it correctly, that is what we are talking about, the prediction, what it is going to say that. So out of the prediction, how many are correct and how many are wrong, depending on that, we are going to give some score. So I have given you 10 samples. Out of the 10 samples, how many of them we have been predicted correctly, how many of them we have been predicted wrongly, depending on that, I'm going to give some score to that particular, whatever the machine learning is there. So what is the main important point here is, guys, machines will learn, but how the machines are going to learn? Machines are going to learn by using something what we call it as algorithms. So the main concept here is, guys, the machine learning algorithms. We are going to use ML, DL, and AI related algorithms. So as we already yesterday discussed, but due to some disturbance, we are unable to discuss it properly yesterday due to some network issue. So here we are not going to, even somebody has asked a question, we are not going to develop any algorithms, guys. Already the algorithms are already defined, already they have been developed by many experts, which are successfully implemented in the real time to solve some real time problems. We are going to apply those particular algorithms to our real time, whatever the problem statements are there, and we are trying to solve the problems, guys. So what you are going to learn in this data science, guys, we are going to learn how these algorithms will work. We are not going to develop them, guys. How this algorithm is going to work. What is the background behind that? That means there is a mathematical topic will be there. Like for example, guys, what is decision tree? There is an algorithm called as a decision tree, guys. Decision tree is going to work based on a statistical concept called as entropy. Depending on the concept of entropy, the decision tree will work. For example, if I talk about k nearest neighbors, it is going to work based on something called as a distance calculations. So how it is going to work? For example, if I talk about something called as a Navi base, it is going to be works depending on some kind of an probability. And even whenever we work with something called as a deep learning applications, guys, deep learning is going to be completely depending on which is going to be a concept called as a derivatives concept, guys. It is going to be a derivatives concept. It is going to be it is going to be depending on that. It is going to be derivatives, calculus concept, guys. So we are going to understand how that particular algorithms are going to work. Those algorithms will help the machines to learn the data, guys. Don't think that machines directly they will learn it. Machines also, they are capable, but with the help of some algorithms only, the machines are able to learn. So those particular algorithms, we are going to learn it here now. Each and every algorithm, how it will work, what is the mass behind them, what is entropy, what is distance, what is probability. At least some of the terminologies you know that, guys. Distance you already know, guys. Probabilities we already know that. Derivative, that means already know means at least we have heard about that. Derivatives concept, you maybe heard about that. Entropy means maybe you have never heard about that. Maybe in physics you have been seen, guys. In law of thermodynamics and all these things, we'll see the entropy concept. That is entropy in physics. This is entropy in statistics. The statistics entropy is different. The whatever the entropy in the physics is going to be different. So how that entropy will calculate? So what is the formulation? What it is going to tells you? What exactly the entropy is going to tells you? If entropy is equivalent to 1, what it means? If entropy is equal to 0, what it is going to means, guys. So that is what the maths and all these things, statistics related concepts, we are going to learn. So we are going to see how effectively we can solve a problem with the help of these algorithms. Not only that, we have a different algorithms are there. For example, if I talk about linear regression, guys, it's an algorithm. It is going to be depending on the status concept is linear regression only, guys. I just shown you some practical example. So it is going to be depending on some basic mathematical linear equations concept only. It is going to be depending on that. Even we are having something like which are going to be, we are having a logistic regression. We have a different algorithms are there, guys. K means we are having an algorithm called as N, which is going to means K means clustering algorithm. So it is also going to be depending on some mathematical topic, what it is, how it will works, how effectively we can make the machine to learn. So all these are going to be the skills what we have to learn, guys. Applying a machine learning algorithm is very easy, guys. But how effectively it is learning, how effectively it has been trained. That is what we have to see about that. That is what a machine learning expert is going to do that. Okay, but it is not straightforward. Directly machines will learn, machines are going to comes with the insights, and machines can't do the prediction. It is going to be something we are going to be gets talking about that, guys. Okay, so leave it, does not matters with that. We'll try to understand how efficiently what exactly all these points. We'll see it in our main classes we discuss about that. Yes, yeah.
As you raised, statistics, I had a doubt, sir.
Yes,
Is
yeah.
this data science is specifically for any most IT backends, or it is also useful for non-IT?
Yes, absolutely. See, I can say that a data science is not a completely, it is an IT related concept. It is not completely mathematical related concepts. We can say that a data science is mainly the combination of three different skills. That is, one is nothing but some little bit knowledge of domain knowledge. Domain knowledge is not a technical knowledge. Domain means, you know, that related to that particular domain we are talking about. A domain knowledge, a maths and stats. It is a maths and stats. And one more is nothing but your IT, which is going to be our computer skills. It is going to be not programmatical skills, it is computer skills. I think you can understand what is the difference between a programmatical skills and a computer skills. Programmatical skills means you should be knowing about logics, what is the functionalities, etc. Computer skills means nothing is there. It is only just to apply some kind of a formulations or apply some kind of a functionalities. That's it. If you know how to use at least some basic programming languages, that is going to be sufficient with that. You need not to be an expert in writing the logics and solving some complex applications. Everything we are going to take the help of the machines. So give the problem statement properly and correctly to the machine. Machine is going to solve the problem. Don't expect that if I directly give the data, machines will learn. The machines also have some standard notation. If I give the data like this, then only the machines can learn. That data, all that particular data formation, data modeling, all these things as a machine learning expert, which I have to do that. So as I said that there is not that much, you need not to be that much expertise in the computer skills. You need not to be that much expertise in the maths and stats. And it is not that much expertise on the domain. So a person who is having some idea of all these three areas, so he can work on the data science related projects. Got it?
Yes,
Yeah,
sir.
somebody, yeah. So it need not to be an IT professional. He need not to be a completely maths and statisticians, isn't it? So a person who is having even if you see the definition of a data scientist also. So a data scientist, when he compared with a software programmer, he was better at statistics when he compared with a software engineer. And he was better at computer skills when he was compared with the statisticians. So compare with the statisticians, they is having a better computer skills. When he was compared with the computer, whether computer expert or software programmer, he was not that much better at software, but he was better at the statistics. So a combination of statistician and a IT professional is going to be makes him to work as a data scientist is going to becomes about that. So that's an idea about the data science. Okay. So coming to the application, guys. So as we are talking about that, we are going, what we have to learn here now. As I said that we don't want to develop any algorithms. Already the algorithms are there, as I already written, decision tree, KNN, Navi base, deep learning, linear regressions. We have so many algorithms are there, guys. We have to learn. Don't count them, how many algorithms we are going to learn, but as many algorithms we have to learn it. And as many algorithms, whenever we got a problem statement, you should be in a position to identify with algorithm I have to solve this. What type of algorithm I have to use, what is a problem statement, how do you solve it? Depending on that, we'll decide the algorithms. So that skill you are going to learn it here, guys. So which type of problems need to be solved by which type of algorithms? We have some rules are there. So based on that particular rules, we can decide these are the algorithms for so and so task, and these are the algorithms for so and so task it is. So generally we call it as classification, regression, clustering algorithms. So depending on the problem statement, we are going to discuss, we are going to decide what type of an algorithm it is going to be there. So that is going to be what exactly we do it in the machine learning. Even in the go to the deep learning, guys, there are going to be some deep learning neural networks will be there. What is a neural networks? So how a neural network is going to work? What is the mass behind them? How to tune a neural network? All these things. As a machine learning expert, we have to make the machine to learn, and we have to evaluate how much effectively the machine is learning. And after that, how to improve the performance also. So today I'll tell you some technical aspects, like how a machine learning problem is going to be get solved. Or let us say that whenever you go to real time and working on a machine learning project or a data science project, what task we are going to perform it, guys. That is what I'll just give you an idea of what are the technical aspects for the today's class. So let me explain, guys, like how we are going to be, what type of skill sets that are required. As I said that no, data science learning is all about learning a different skills only, guys. You have to learn a different types of skills. So what type of skills we have to learn, guys? The first skill is going to be nothing but how to collect the data. Data collection is going to be one of the skill we have to learn it, guys. So don't think that data collection is very easy. Data, what is meaning of data collections? Just getting the data. No, guys. Nowadays, data is going to be available in multiple formats. It's not just like one or two formats, guys. There are hundreds of formats are there. So how to read or how to collect your data? So from different systems. Maybe the data may be there in a CSV file or Excel sheet, database system, or nowadays we are using cloud. It's going to be cloud systems. So whenever the data is available in some particular location, how to collect your data, how to get the data. So that is going to be one of the skill we require, guys. Here also, guys, we are going to learn a different types of collecting the data from different type of systems. Normally regular files, guys, like CSV, Excel sheets, etc. Apart from that, we are going to see how to read the data from database systems. Mainly nowadays it is available in the cloud. Mainly how to import the data from the clouds, cloud storages, that also we are going to discuss about. So it may be in Azure, or it may be in AWS, or it may be Google Cloud Platform. Wherever the data was there, we are going to be extracting that particular data. I'll tell you guys. Okay, fine. So apart from that, okay, after the data collection, so as I said that no data, after you collected the data, as it is, if you feed the data to the machine, machines may learn it, but may not be effective. So first of all, we have to analyze, we have to verify whether the data is in a proper format or not, whether the sufficient data is available to learn, whether the sufficient it is going to be learned or not. We have to, first of all, we have to do that. So for that, we have to learn some basic data analytical skills, guys. They are called as a data analytical skills. So this is going to be generally in our data science, we call it as a task called as an EDA task. We are going to call it as exploratory data analysis. It is what we call it as an exploratory data analysis is what we call it as. In short, we call it as EDA. So one of the main important the task or the main important stage in our data science project. In every data science project, first there must be some EDA must be there. So as part of EDA, what we are going to do, guys, data analytical skills we have to learn, guys. So whenever the data was not in a proper format or it is not in a sufficient format, we have to clean up them, guys. That is also one of the skill, guys. The skill is nothing but what we call it as a data cleansing skill. So these are all some kind of a skill sets, guys. We are not going to be, whether you use a tool, whether you use a language, I don't bother about that. We have a different tools are there, different data cleansing is there, guys. You can do it in Excel sheet, you can do it in Python, or you can use it in R, you can use it in some other language or some other tool, does not matter. But we should know about like what is meaning of data cleansing, what type of issues you are going to get in the data. So how do you solve them? What is the best option for that? All these are going to be some of the skills we have to learn it, guys. The next option is going to be, guys, data visualization. All these three is going to be comes under the EDA part. Again, the same part. Data visualization means some people immediately get set out. So shall I have to learn something like any Power BI, Tableau? I'm not talking about a tool. I'm not talking about a software, guys. It is a skill. What is data visualization skill? Whether you do it by using Power BI, whether you do it by using Tableau or a Python or R, does not matter. You should know what is data visualization, how to use a different visualizations for our understanding. What type of visualizations are going to be helps you to understand the data. All these things you have to know the skills, guys. Who is going to do all these skills, guys? Who will collect the data? User. Who has to do the data analytics? User. Who is going to do the data cleansing? User. Who is going to do the data visualization? User. All these skills need to be performed by that machine learning expert only, guys. Machines are only capable to learn the data, but machines are not capable to clean the data. Machines are not capable to visualize the data, guys. Everything that has to be done by the user only. So once a machine learning expert performs all these operations, then whatever the data he has been prepared, the data model, what we call it as, the data model will be given to the machine. Machine is going to be trained on the data model, guys. Whatever the data model is created, on that particular data model, we are going to give the machine, we'll give the data to the machine. Machine is going to be given some training on that. That is what we call it as training, as what we call it as model training or model fitting, where the machine is going to learn from the data. Okay, machine has learned the data, guys. Machine has learned something from the data. But after it has been learned, that is what we have to do is how much effectively it is, just like a human learning only, guys. Only the thing is humans require some time to learn it. So see, we have studied, for example, we went for a school. So 1, 2, that is the first standard to the 10 standards. So stage by stage for 10 years, we have been trained at the school. After that, at 2 years at something at approx 2 years in the college. After that, another 4 years or another 3 years at the bachelor's. So now you have became an expertise. Now you are capable to solve some kind of a real-time problems. Same as it is, machines also is going to be given some proper training. In school level, college level, what they will do, guys, they are going to teach you something. We have been learned something from in the college or in the classroom. After that, how much effectively you have been learned, how much effectively you understood the concept, we have to evaluate you. For that, we'll conduct a test. Same as it is here also, we are going to make the model to model evaluation, what we are going to call it as. Evaluation is nothing but how much extent it has been learned is correct. Up to what extent this is going to be, what this machine has learned is correct, we have to study about that. And once the evaluation is over, evaluation means like this, guys, 90% it learned correctly or 100% it has learned correctly, something like that. For example, it was giving only 80% only, guys. Then how to improve it? Can I improve them? Yes, that is nothing but what we can call it as improving of model performance. It is what we call it as improving of the model performance, guys. The machine learning model will be there, right? It is what we call it as a model performance. So we can increase it. When you can increase? Only whenever we know how the machine is working or how the machine has learned, how the algorithm will works. If you know, then the machine, the particular machine learning is going to be comes to your control. Within our control only it will learn, guys. Based on our instructions, based on some applications, which one is effective, we have to explain them. We have to explain them. Like for example, guys, just an example, if I say, for example, for a small kid, for example, if I say 25 into which is going to be 16, if I explain like this. Now, as an adult, you know that how to do it, guys. How to do it, we already know that. Directly, we know that 16 5s is going to be how much, guys? 80. So 16 2s is going to be nothing but this much. It's going to be 32. 32 plus which is going to be whatever the 8 is going to be 400. As an adult, you can calculate it. But if I explain this to a small kid of who is studying at 2nd standard or 3rd standard, he cannot understand it. So he knows only multiplication of numbers only for a single digit number. Then we have to explain like why it is going to be. So 6 5s, which is going to be 30, 6 2s, which is going to be 12. So how we have been explained them as part of that. Why you have to write here? Why don't you write here? Okay, we have to explain that this is tens place. This is units place. That's why we are writing in the tens place. Why don't you write 150 here and why don't you write this particular 25 here? And why don't you add it? Why you are placing in tens position? Because the place value is tens. This place value is hundreds. That is the reason why we have to put it. So slowly how we have been studied about that, same as it is, we have to train the machines also. If you train it properly, the machines will learn properly. Otherwise, machines will learn. Machine never says that we don't learn. Machines also going to learn, but my learning is only 70% correct only, or only 60% correct only. I can't learn more than that. I can't learn more than that. So we have to improve the model performance, and finally, we have to do the deployment. So out of these 7 or 8 steps, guys, only this step is the only step where the machine is involved. Only that step is the step where the machine is going to be involved, guys. Where the machine is given some data and the machine is going to be trained, where the machine is going to do that. Remaining all of them, we have to do it by ourselves only, guys. As a machine learning expert, we have to do that. We have to evaluate, we have to improve the performance, we have to tune it, and we have to do the deployment. So deployment anyhow, the concept is same concept only. So machines can't do the deployment. As a user, as a machine learning expert, so we have to perform the deployment of that particular model. So that is the way. So these are the main important steps, guys. You see any machine learning or machine learning process, guys. So they says that first, before that, they will say that first of all, we have to understand the problem statement. That is obviously whether you work with machine learning or a Java or any programming language. First of all, what is the problem statement? Yes, first understand the problem statement. After that, what we have to do? This is the steps what we have to do, guys. Yes, absolutely, guys. Whether you apply a machine learning, deep learning, whatever the concept you apply, guys, these are going to be the steps involved in here. These are the steps. These are the steps which are going to be involved here, guys. Let us say that what is going to be machine learning, which is going to be pipeline, or what are going to be the machine learning steps, guys. So whenever we talk about the machine learning steps, guys, how the machine learning is going to be gets done. Can you see, guys? Can you see the process, guys? For example, if we talk about, let us see this one. From Simply Learn, I'm going to showing you guys a complete guide. So of how the machine learning is going to be gets done. 7 steps, 8 steps, whatever they say, guys, nothing matters it out. Observe carefully what is machine learning. All these things you put it aside. So what are the machine learning steps, guys? They are saying that 7 major steps, 8 major steps, whatever it may be. First, collect your data, guys. After collecting, what we have to do, guys? We have to do some data preparation. In the data preparation, what we have to do, guys? Visualizing. We have to do something called as an visualizing, guys. Can you see? Cleaning of the data we have to do. We have to analyze the data. So we have to analyze that particular data. All these things we have to do in the data preparation. After that, I told you, choosing a model. Choosing a model means which model is going to learn. The machine learning models will be there. After that, we have to do the training, guys. This is what we call it as model training, what we are going to call it as. Model will immediately learn. In this step only, guys, the model is going to learn. And finally, it is evaluation of the model. And after that, it is possible, let us do the improvement, tuning. How to improve the performance, guys. That is what we call it as tuning. And finally, the deployment, guys. That is going to be making predictions. I said it is going to be deployment concept it is. You ask anybody, guys. You ask anybody what is a data science, what steps you will do. Same steps, guys. What will changes? The only thing that is going to be changes is, guys, the algorithm is going to changes. Remaining steps are the same step. Whether I apply a decision tree algorithm, whether I apply a KNN algorithm, whether I apply Navi base, only that algorithm is going to be changes during that particular training procedure. Only that algorithm changes, guys. But remaining procedure is the same. Whether you work with decision tree, first collect the data. Whether you're working with Navi base, collect the data. Whenever you are performing a data visualize, when you are performing this one, we have to do that particular. Any algorithm, first of all, we have to collect the data, guys. Collect the data, analyze it, cleanse it, visualize it, and give the training. And after that, evaluate the model performance, how to improve, tune it to get a better performance, and go for the deployment procedures. So the main important here is, guys, algorithm only. So what is the reason behind why the machine learning has become popular? Machine learning was started in year 1959, guys. The research has been started in 1959, guys. It was started by a person called as an Arthur Samuel. A person called as an Arthur Samuel. He was an employee in IBM. While he was working at IBM itself, he has coined this term called as a machine learning. He started doing the research. Why machines has to be instructed? Can't machines can learn? So what, according to Arthur Samuel, if you see the definition of machine learning, he says that we are giving the ability to the computers to learn without explicit coding. The definition says that one only, guys. If you ask about Arthur Samuel definition, according to the Arthur Samuel, what is the definition of machine learning is giving the computers the ability to learn without explicit coding. We don't write any coding at all, guys. Machines will start learning the data.
But
That is what
sorry to interrupt, but what
Yeah.
actually, when you say we are not giving any coding, but we are pushing some model, we are developing some model, and then we are telling the machine, right? Here also we
Yes.
are doing some kind of coding only, right? I mean, model we are preparing.
Obviously, that is a data model we are preparing. So machines
Okay.
can't learn the data in whatever the format you give. There is some data model is there. In this model only we can work. In this model only we can learn. So that you cannot understand it as of now, because if I use the terms like features, and if I use a term called as a target, maybe you can't understand that. So for every machine learning model to learn, there must be features must be there, there must be target must be there. If you give these two values only, the machine is going to learn. So that modeling is what we are going to do it here now. First, before giving the data, first of all, we have to prepare the data model, and then we have to give the data to the machine, then machines can learn it. Okay.
Okay.
Fine. Right, guys. So this is the one which we can see. Yeah.
Yeah, Vamsi. For
Yeah.
example, my score is 60% and I want to increase this 80% score.
Okay.
And what's the precautions too? What's the precautions I need to take?
Precautions means it is going to be depending on the two things. One is depending on the data what you have been chosen, and apart from that, whatever the algorithm which you have been chosen. So there are some techniques are there. So based on that particular technique, we are going to do. I'll just tell you some example. Maybe it's an you cannot understand the concept, but let us say that you may be heard about. For example, if this is point A and this is point B, okay, what is the distance between A to B? For example, if x1 is having a coordinate of x1, y1, and B is having a coordinates of x2, y2. Just an example. So do you remember how to calculate distance between A comma B? What is the formulation for A comma B?
I think so. Yeah, I think so. Y equal to mx plus c.
No. It is, I'm talking about the distance. You are talking about equation of the line. Okay. You are talking about what is the equation of the line you are talking about. I'm asking distance between A to B. It is x1 minus x2 square plus which is going to be y1 minus which is going to be y2 square and whole to the square root. This is what we call it as a distance. So just I'm telling that. So an algorithm is going to be working based on the distance calculation. Let us say that as you are saying that it is giving 60% accuracy. Then I'll ask the machine saying that, so what is meaning of I want to travel from A to B? You can travel from A to B either directly like this, or we have another process is there. You can travel from here to here, let us say point C, and we can travel from A to B, from C to B. Now the main point is I want to travel from A to B. I can directly travel like this, or A to C and C to B also I can travel. So you can easily, if you are a little bit, if you remember the mathematics, so this point is exactly parallel to this point. So y coordinate will be the same. This point is exactly parallel to this point. X coordinate will be the same. So this point is going to be x2, comma, which is going to be y1. So what is the distance from A to C now? The distance is x1 minus x2. What is the distance from here to here? It is y1 minus y2. So now if I want to travel from ACB distance, it is modulus of x1 minus x2 plus which is going to be y1 minus y2. Don't worry. This is what we call it as an absolute distance. Generally in our school days, we don't learn this concept. We will learn only this concept only. This concept we are not going to learn. If you remembered or not, this is what we call it as Euclidean distance. If you remember at the school days, the distance what you correctly calculated from A to B is Euclidean distance. This is what we call it as an absolute distance. So I'll ask my model, instead of calculating this Euclidean distance, go for a which is going to be this particular distance, because the distance, whatever the concept it is using, it may not be working properly. Then I don't say it will always improve the performance. It may become 80% or it may become 40%. So how you can do that? You know that if you know that you can make the machine to learn by using the Euclidean distance, and you know how to make the machine to work on the based on the absolute distance. If you know that metric, then you can do the you can make the machine to tune that. So that's the reason I'm saying that we have to understand how the algorithm is going to works. If you know how the algorithm will going to works, we can change these parameters and I can make the machine to tune itself. There are some techniques are there. Really, we cannot make you understand now itself. For example, if I talk about the KNN algorithm, to whom you have to give a preference. So the closest distance need to get a higher preference. Some kind of a techniques will be there. Using that, we can make the machine to learn it. Got it?
Sir,
Yeah.
Here,
Yes.
Yeah,
date,
yeah, got it.
if
Yeah.
we have if we had two sets of data like A and B, is the same code can be applied for A and B? I mean, if the requirement is same, or
Okay, you're saying that if data set is the same, the solution which we have applied to the first set can be applicable to the second set also.
no, sir. We had two sets of data, which is
Okay.
a kind of similar data from likewise we can take an example like class A and class B.
Okay.
Okay. For the both data sets, we need to analyze the data and give an output.
Yes, absolutely.
Is the same code can be used for class A and class B, or we should change the code, sir?
No. Code, see, here the concept is code is not important. Coding is not important here now. It is nothing but how you are analyzing the data. So you are saying that data set is the same. Data set is very similar data. So if it is quite exactly similar data, we don't have any problem. Whatever the techniques we applied there, it is going to be there. But only the thing is, here the data is not important. It is going to be what we call it as distribution of data is important. How the data was distributed is going to be important. So coding part, we don't give any preference in the data science. What is coding? You forgot about that. What analytics we are doing, how you are understanding the data. Can I apply the same skill? You have another data is there. Can I apply? For example, I have a bank data is there, one X bank data. Let us say that you have experience on this bank data set. Now you have been shifted to another bank Y. Can I apply the same skills as it is here? Yes, we can apply it. Provided if the distribution of the data is going to be the same. Same data will be there. There also customers data, their only loans data. Domain is the same, but depending on the data only, we have to change our analytical concepts also we have to change. So maximum in real applications, even the data set is the same, we are going to find a different solutions and a different analytics we have to follow that. It completely depends on the nature of data. It completely depending on the whatever the distribution of the data. We cannot say that we can apply the same skill set on the same techniques on the other data sets. If exactly the distribution is the same, if exactly the relation holds the same, then we can apply that. Coding part, it's a leave it. Coding part is not at all preference here now. That does not have any importance here now at all.
Sir, actually, I have one doubt. You
Yes,
mentioned so many machine learning algorithms earlier. So how do we know, I mean, which algorithm exactly we want to choose for this type of data? For example, if we
as I said that no, it depends on the problem statement. I clearly said that it depends on the problem statement. We are going to decide which type of solution we have to use it.
Okay, I have, I mean, for example, if the data set is for classifying, okay, in this case, an interviewer will ask me, so since these many algorithms are there, why are you choosing that? You can go for any other algorithm. On what basis you are choosing this algorithm?
That's why I'm saying that. That's why what I'm saying is, which one is going to be that means depending on how we are solving the problem. Okay, like for example, just an example, easy to make you understand that. Let us say that, just an example I'm talking about that. Let us say that you want to go to one of the shop at your home. For example, I want to go to a shop. So there is going to be multiple shops in your location. So tell me just an idea. how do you decide this? Which shop you have to go? So what are the different criteria you are going to choose? Can you tell me one simple criteria?
Yeah, based on the purchase, I mean, of things, we decide that.
Okay. Okay. For example, 3 grocery stores are there. You want to go to a grocery shop only. So which shop you are going to go now?
To the nearby one.
Obviously, you are going to be saying nearby. Okay. But whatever the nearby that was there, let us say that the quality of the products is not good. The customers' reviews are not good. Then what you are going to choose now? So I hope you understood the problem now. You have a different criteria. One criteria is you are saying that distance, which one is the distance is less is one criteria. Second criteria maybe it is going to be the reviews of that particular, the customer's reviews. In the same way, whenever you want to solve a the problem, as I said that, depending on how you are going to choose, how we are going to solve the problem. So are you going to split the data and you are going to do that? Now you cannot understand that, but we have a decision tree and a KNN. Which one is going to be better suitable for that? It depends on the nature of the data and the depending on how we are going to solve the problem. For example, if you want to, so let's say that you want to decide based on the distance. Obviously, you are going to check in the Google Maps which one is the closest one. We are going to do that. Second case is you are going to check for the reviews. So which one is having a good review? Even the shop is far away, you are going to do that. So criteria is a different case. Same as it is in machine learning also, when you are choosing the algorithm, the problem you are trying to solve, depending on the nature, all these are going to be decides you, or it is going to make based on that, you have to decide which algorithm you have to use. Got my point?
Yes, sir.
Okay. So that you can understand, that means because see in the beginning itself, we can't decide that, but obviously we have a decision tree. As I said that no, it depends on divide and conquer mechanism. A KNN is there. It is going to be depending on the distance calculations like that. It is going to be works. So once you start working on the algorithm, then you will understand that. So depending on what, for example, you take a Navi base is there. So what the Navi base is going to do, guys, I'll tell you. Let us say that you take, let us say that, for example, Navi base depends on the probability concept. So Navi base is going to be depending on the probability concept. Like for example, you take 10 customers. Let us take 10 customers. How many times they went to the shop 1? How many times they went to the shop 2? How many times they went to the shop 3? Out of 10 cases, 10 times he is going to the shop 1. So he'll say that I'll go to the shop 2. Hope you understood. It is depending on some probability. One is depending on the distance. One is going to be depending on the whatever the reviews. So how you are going to decide depending on some different criteria. Machine learning is also the same way. So the problem statement is important first of all, as you are talking about some terminology, because I think you have some little bit knowledge because you have spoken about a word, you have used a word called as a classification. So what are classification algorithms? Decision tree, KNN, Navi base. We have something like an SPM, or we are having something called as a random forest. So these are all some kind of an classification algorithms. They will solve the classification problems. So if you are working with regression, we have a linear regression, we have a logistic regression, we have a ridge regression, or we have a polynomial regression. So depending on that, we are going to choose as that particular algorithms. So depending on the problem statement, depending on the nature of the data, we'll decide that algorithms, but not like any thumb rules like if this is the data, you have to use this. If this is the data, we have to use. Not like that. It depends on the type and how to solve your problem also plays an important role. Right, guys. So that is about the concepts, guys. So I think it's a little bit complicated for some of the people maybe to learn to understand at a higher level. No worries. All these technical aspects, we are going to learn it in our actual course curriculum. We are going to learn it, guys. Okay. So anyone, guys, any questions if you have?
I have one question. I'm
Yes.
just confused with this one.
Yes.
So when there is a data model, you are mentioning the 6th step or 5th step data model, we are going to create it. That data model.
Yeah, we are going to train it.
Okay. Before we are training to the machine here.
No. We are training. We are giving the data to the model. Before that, we have to prepare all the data model need to be created by doing some data cleansing, by using some analytics, whether what type of data, process it, convert into some other different features, do some data visualizations. There we have to prepare something called as an, correctly speaking, we have to prepare something called as an training set and the testing sets. We have to prepare it. It should be in the format of X and Y. X is the features, Y is your target variable. So we should have the X and we should have the Y. That is what the data model is required for making the machine to learn it.
Okay, so X is your input and Y is your output.
Output,
so
yeah,
that,
absolutely.
Okay, so this training and test set to prepare this one, any data science tool is required or existing? We are applying in.
You don't do anything here now. That means, first of all, you have to understand why training, why testing. What is training, what is testing, we have to run. So you didn't get a doubt, but in actual class, you will get a doubt. Why training, why testing? What is the reason why we are training? Okay, why do you require the training set? Why do you require a data set? That is it's a very tough to make you to understand the concept. It's not like a programming language. In programming language, what you will do? You write a program. You are going to give the input and you are going to test it. What is meaning of testing means whether the program is working correctly or not. But here the problem is not like that. It is predicting the future. It is predicting the future. So whether it is whatever it predicted is future is correct or not. For example, let us say that yesterday I just discussed about an example of a loans. So today a customer applied a loan. The machine predicted that he is not going to be a defaulter. We can give a loan. So based on the machine prediction, the bank has given the loan. But in the case, if he becomes a defaulter, will he becomes a defaulter immediately on the next day? No. After 2 years, he stopped paying the EMS. That means you came to know that the prediction what the machine has done is wrong after 2 years of time. Isn't it? So that is one of the problem is there. So how to solve it and all these things I'll tell you. Don't worry. Just an example I'm saying. Just let me show you some data. Import. I'm importing a pandas library. I'm not going to use any tools. I'm going to use a Python language. Why Python? Because Python provides you all the utilities for your data science and machine learning concepts. All complete libraries it will provide you. Don't worry about that. I'm using a simple cars data set, just a small data set. Read CSV. Let us say that I'm going to say C:/data/ it is used cars.csv file. Don't worry, don't worry guys. Just I want to solve some kind of a problem. This is your data set. Now I'm saying that X, for example, I'm taking X equal to, let us say that I'm going to take the two features. I'm going to take it. One is the price and one is the mileage. And what is your Y? Y is equal to nothing but I said cars of it is model. For example, execute it. So I think you have some little bit idea. So you got something like what is X and what is Y. I said X is input, Y is output. Now what I have to do now, I have to split this data into train set and test set. First of all, you have to understand what is training, what is testing. How much percentage for training, how much percentage for testing. That data set only we split it. But how to do that? For that, you need not to write any tool. Why? Because in our Python, we have a library called as an sklearn library is going to be there. Using this library, you can do all this kind of a process. So that's why I said that doing this particular train_test_split. So performing the operation by using some code is not having an importance. You should first of all, why I'm splitting the data into training set, why I'm splitting the data into the testing set. Once if you know that, remaining, I can just give the idea about that. The programmatically we are going to do. So I'll do that train_test_split. It is X, Y. It directly splits the data and gives you total 4 data sets will come. What is your X train? What is your X test? What is your Y train? What is going to be your Y test? That's it. We are going to get the data like this. This is the coding part. But why I'm doing the training and testing is first of all what you have to understand here. So I splitted the data set. Can you see here how many records we have?
Yeah, 150.
150 records. It will splitting the data into 3/4. That is 75% into training, 25% into testing. So what is 3/4 of the 150? You can say what is the what is going to be the 3/4 of the 150? 75% of 150. So I think how much it is going to be? 113, right? 113, 114. Because 37.5 is the 1/4. 38, if you say that 38, if you take it, means it is going to be something around 112 or something will be the data. So if you see the x dot shape or x underscore train dot shape, this is going to be somewhere around 112 records. What is the testing sample contains? Your testing sample is going to contains the remaining 25% of the data. That is 38 samples. Did I written any coding for that? I didn't written any code. It is a function which will help you to do the sample. So programmatically, how to do it does not matter. It is only the thing is, which is going to be something like what we can say is, it is just the idea of how to work with that. So once if you know what is training, what is testing, so applying that particular formulation is going to be done by the Python itself. So we don't use any tools, but completely done by the Python tool. The Python language only we are going to use this. Got it?
Vamsi, I have a question.
Yes, yes.
Yeah, this is Narendra.
Yeah,
Actually, user has 1,000 records, for example, and the user can provide 300 records only. Okay. And how can I tackle rest of all 700 records?
That means what is the problem with the 700 records?
Yeah. I mean, for example, user has 1,000 records, and he don't want allow. Yeah, okay. Yeah, he has 1,000 records, and he don't want allow to. He can allow only 300 records only.
Okay.
But he don't want allow to 700 records.
Okay.
That scenario, how can I tackle that situation?
Yeah, obviously, see, I have 1,000 records. I have 150 records with me, right? In this case, for example. So if I want to make the machine to train only on 100 records, I can just filter the 100 records and I can give only the 100 records to the machine. I don't have any problem with that. So what you are asking is that means how do you restrict the number of records?
Yeah. No. Yeah, my question is actually user has 1,000 records and he has he gave permission to me 300 records only.
I don't say in that case what I will do is, for example, in this case 150 records are there. For example, in the case 150 records, what I am going to do is I will pick some random records from this. Let us say sample. I don't want to pick sequence of records. So the data set name is going to be cars dot, which is going to be sample of. I want to pick only 50 random records. I'm going to prepare it. So these 50 records, what I'm going to do is I'm going to write it into CSV file. And I'm going to give you only this particular 60. This sample, I'll give it to you. Instead of giving the entire data set, I'll give this data set to you. You will get only that 50 records only. So sample underscore cars.csv, if I say, I'm going to be giving you only that particular 50 records. Now that data set, whatever the sample underscore cars.csv is there, it will contain only that sample 50 records it will contain. Now I'll give only that particular 50 records to the other person. Here we can't maintain any securities and all these things we cannot maintain because it is completely like a programming language. So I can restrict on a database, but here I can't restrict any such kind of a data. We are importing the data and we are going to be working. For example, let us say that I want to make you to work. I'll say that I don't give this cars data set. I'm not going to give you this data set to you. I'll give you only this data set to you. If you see this data set, you'll have only 50 sample records.
Okay, got it. Yeah.
Okay. So all that work, whatever you want, I can show you the data. So where is the data is there? It is there at the C drive. I have a location, C drive. I have a data folder, and inside the data folder, I have this particular file. The name of the file is going to be this file. If I open this file, you can find the random 50 records, whatever I have selected, only that particular random 50 records will be there. You can see this. This is going to contain how many records it contains. It contains 50 records. Only that particular 50 records are available here. Okay. Fine. We are not maintaining any security. We are not working on any particular system. It's a program. It's a language. So we have to import and we have to work. Okay. So guys, the one thing is without starting with any application, we cannot just study the concept, but just try to understand like what we are going to do. What type of applications we are going to do, what kind of a scenarios we are going to implement. So that is what I can explain in the concept here, guys. Okay. All these things, technical aspects, when you go to the main class, we are going to discuss about that. Okay. So hope all of you have been got clarified with all your questions, guys. Obviously still lot of questions because even myself also, I didn't understand why machine learning will be used initially. What is the purpose? Now a lot of scenarios we got in, guys. Okay.
Actually,
so fine. Yeah.
Yeah, Vamsi, actually, if you have time, can you explain about operation recall F1 score? If you have time.
That you cannot now. I can't see. I can explain you what is precision and what is recall values.
Okay.
But only the thing is, I was an expert in that. I was an expert in that. But first of all, if I want to make you understand, I have to first of all make you understand what is confusion matrix. So I clearly say that. I clearly say that also. If you want to test a person whether he is having a skill of machine learning or not, you ask these questions only. Okay. If you can explain clearly, if I can explain clearly this, he was an expert, no doubt. He was remaining part, you can leave it. If you can explain clearly what is confusion matrix, that is going to be sufficient. For example, let us say that in our case of, let us say, talk about an example of a diagnosis, a medical diagnosis. I'm just telling you, this is positive cases. First of all, if you have the idea about confusion matrix, so obviously I can expect that if you are talking about those parameters means you have some idea about that. Okay. So let us say that this is your actual values and these are your predicted values.
Yeah.
These are going to be predicted values. So how many positives predicted as positives is called as true positive. Positives negative predicted as called as an false, false negative. And negatives predicted as positives are false positives. Negative predicted as negatives is true negatives.
True negative, yeah.
So what is precision if you talk about that? Out of the total positives it predicted, without seeing the table, I can say I was an expert in that. So nobody nobody can explain you that much clearly, like TTPP by without TP plus, which is going to be FN. What is going to be F1 score? F1 score is harmonic mean of, which is going to be precision and the recall. 1 by P plus, which is going to be 1 by R. So indirectly, F is equal to 2 into P into R divided by P plus R. So that is
actually don't mind. Okay, just curious about it.
No problem at all. Only thing is, without knowing, see, I don't expect that. See, what generally expect is you came here for learning means obviously my expectation is you don't know anything about that. So obviously if you know that, some people may have the idea, but to learn more and more efficiently, because maybe you have learned in some other trainer, you didn't understand it clearly. So you want to learn it. So you want to test me, obviously, how much extent this person knows about that. So clearly I'll take this. This is what we call it as evaluation. This is what we are going to do it in evaluation of model performance, precision, recall, F1 score. Nobody will teach you perfectly about the ROCs. I will explain the ROC, receiver operating characteristics, AOC, AUC, area under the curves. All these things, I was an expert in that. So I can clearly explain what is true positives, what are going to be TPRs, what are FPRs, what is a true positive is 1, what is FPR is equal to 1, what is TPR equal to 1, what is FPR equal to 1. Meaning that is all samples are predicted as positives. Then TPR will be 1, FPR will be 1. So what is the ideal case? TPR should be higher, TPR should be 1, FPR should be equal to 0. This is an ideal case which we recommend that. So that depends on the confusion matrix. No, don't mind. I can understand because if you know the confusion matrix, I can explain because from the confusion matrix only we do all this.
Yeah, that's true.
Yeah. Fine.
Yeah, thanks for the explanation. Yeah.
Sir, after that we will deploy where we will deploy the code, sir.
Where we
deploy the code. Yeah.
Not deploy the code. Here it is going to be your ML model will be there. Not the code. Coding is not going to be deployed. We are going to deploy the ML model we are going to deploy. Normally we have a local system which is going to be like a pickle file. We can do that, or else we are going to be deploying on the cloud architectures. We are going to deploy it. We'll mostly do it on the cloud architectures, mostly because we can access from anywhere. If we deploy in the local system, I have to share the pickle file. Instead of that one, if I deploy it in the cloud, directly anybody using that cloud, whatever the keys are there, they can access that applications.
Yeah, okay, thank you.
Fine. Right, guys. Okay, so hope all of you has been today because I generally I take a demo classes. Generally people will be very silent because they don't know about much about that. But I expect that maybe these guys, that means whoever the participants in this batch, there are some working professionals are there and they already knows some little bit idea about the data science. That's why they are talking in a technical way. Because really I also enjoy, because if you also, if say simple questions like how much is a course fees, what is the course duration mean? So that's questions are going to be, nothing is going to be matters for me. So technically, if I also get the question from your side, so I will be also very happy to explain that. Okay. Yes, somebody,
Yeah, myself,
yeah,
Ravali.
Ravali,
This
yeah.
is Ravali. I would like to understand, like, I mean, this is all theoretical that we are looking at, right? How much of technical knowledge are we going to get? Because this implementation, when it comes to the implementation part, it is very much necessary that we also know the programming. We also have the programming skills equally, right? So,
Yes,
how
yes.
much of the content are we going to learn?
Everything, main important here is concept as well as this implementation. Here both are having the equal priority.
Yeah,
so
exactly.
We don't teach only the theoretical concept, we'll teach you the theoretical as well as we also show you everything practically. Just observe carefully, just an example to make you understand. So I just talked about something, even I don't know how much extent you understood that. Precision is having a formula by TP plus FP. So you know this. If you don't know this concept also, you don't know what is the precision, what is the recall. Even if you don't know that, I don't have any problem with that. Why? Because there are some libraries which are going to provide you all these guys. So like for example, in sklearn, as just now I told you, everything is readily available. From sklearn which is going to be, these are called as metrics. So in metrics we'll be having, so which is going to be import. I have a something called as an precision score is there, recall score is there, and everything. So you can calculate it. But if anybody by hand, if they given you the confusion matrix and ask you to calculate what is precision, you should know the formula for that. So formula is important as well as how to do that as part of this one. But if you know the formula, you can do by hand also. You can do, somebody has given this confusion matrix and by hand, if you want to calculate precision, you will be in a position to calculate it. So concept as well as theory, both will be there, practical and concept. Just I'll show you like how our classes will be there just before session. It is just before your session only. It is which batch? It is 6 p.m. batch. So today, what is the today's date? 29th, right? So it is 29/8/2023 6 p.m. just 3 hours before. So this is the code what I have been explained in that 6 p.m. batch. Just before your batch only, I just explained what are the different scenarios, how to work with them. So today I discussed about something about renaming, calculating the cumulative sums, how to calculate the cumulative products, so how to rank them. So all these things I have explained the concept in the today's class. So this is whatever the practical concept.
So we will be taught Python from the basics.
Python. From the basics. The basic means some basic level of Python is required. Basics only. So up to whatever the extent you require, that I will explain you.
Okay. Rest all we will have to work out ourselves and learn.
It's not required. That is it optional. If you want to learn, you can learn it. Otherwise, whatever the basics that is sufficient. That means to apply all the machine learning concepts, what basic Python is required, that concepts I'm going to teach it in the class.
Okay. Libraries related to data science will be taught in class.
Pandas, NumPy, Matplotlib, Seaborn, all these libraries we'll discuss it.
Okay. The reason why I'm asking this question is I don't have any experience on Python.
It's not at all required. Even if you have zero knowledge, also no problem.
Okay.
If you have do you have any programming language skills? Other programming language?
I'm from ETL background. I do
ETL. Excellent. Basics, right? Okay, that is sufficient. That is just a basic programming sufficient. Okay. Fine, guys. It's already 9:45. Okay. So just for today, we'll end the session, guys, and we'll continue in the tomorrow's class, guys. Right. So thanks all of you guys. We'll meet up in the tomorrow's class.